Dear students, welcome to my 7th lecture of subject Principles of Electronic Communication. In this lecture, we are going to see the electromagnetic spectrum and frequency and wavelength concept. In your syllabus, this topic covered first and then this topic is going to be covered. In this lecture, we do reverse. We do first see what is frequency and wavelength. Once it clears up the concept of these two, you can easily understand the concept of electromagnetic spectrum. So for explaining concept of frequency and wavelength, I prefer one tool, that is MATLAB. Here you can see MATLAB and its version is 2019. This tool is new to you, but it will clear up the concept of frequency and wavelength using small scripting. This tool is not in your syllabus, but though it will help you to understand. Here we take time of 1 second, which ranges from 0 to 1 second in steps of 0.001. This is the syntax of that software. For simplicity, you can only remember that we are using time of only 1 second. We consider frequency is 1. As you all know, the unit of the frequency is hertz. So it is 1 hertz. Then we take one variable y, which is equal to sine of 2 into pi into frequency into time. So this is standard equation of sine waveform to represent sine. Then if we plot our time with respect to the y, this is also syntax of MATLAB. This is a simple script. If you save the script using frequency underscore wave name .m is for MATLAB file, and if you run that file, you can see very beautiful waveform of sine. This is a sine waveform. See, from 0 to 1 and again 1 to 0, 0 to minus 1, minus 1 to 0. If we take this waveform from this point to this point, you can see that the distance is only 1. So x-axis is showing seconds, 1 seconds. As per y-axis is concerned, for example this one, this distance, y-axis distance, you can see it is also 1. Means this is 1 volts of the sine waveform, and you can see only 1 cycle in 1 second. That's why this waveform is having 1 hertz of the frequency. So I hope you have understood about the concept of frequency. To clear frequencies concept more, I modify this script by only changing one variable's value, that is frequency's value. Instead of 1, I use 2 and save this file. You can see here. So in a previous attempt it was only one cycle, but now you can see 2 cycles over here. And the distance between these 2 points on x-axis is again 1. So this is 1 second. But in 1 second, instead of observing 1 cycle, here you observe 2 cycles. The meaning is that the frequency is 2. Means in 1 cycle, if in 1 second, if 2 cycles observed, then frequency is 2. If in 1 second, 3 cycles observed, then frequency is 3. So likewise, frequency means in 1 second, how many cycles observed of a particular waveform. So I hope you have understood the concept of frequency. Now as per wavelength is concerned, when we are taking distance between the peaks, for example, this is the peak point of sine waveform which is at 1 volt, this is at 1 volt. So when we are taking the duration between these 2 points, that is called as crest. Or if we are taking distance between 2 troughs, or you can say these are the peaks, 2 peaks or 2 valleys. These words are quite simple for you. 2 valleys or 2 peaks. The distance between these two is called as wavelength. So this is wavelength, the distance between 2 peak points or 2 valley points. Okay, and as it is a distance, you can prefer, you can use meter, or you can use centimeter, or you can use millimeter, you can use micrometer, or you can use nanometers to represent our wavelength. So I hope you understood about the concept of frequency and wavelength. Now we will see basic unit of the frequency and wavelength. Now as here you can see, frequency can be represented by hertz only, capital H and small z. This is hertz, the name of the scientist who have invented the waveform and frequency, concept of the frequency especially. 1 kilo means 1000 and hertz is a unit of frequency. So 1 kilohertz, rather you can write down 1000 hertz more specifically, or 1 mega, capital M is mega. 1 megahertz means 1000 kilohertz or 10 raised to 6. You can easily remember this. For 1 mega it is 10 raised to 6 hertz, and giga means it is 10 raised to 9 hertz. So 1 gigahertz is equal to 1000 megahertz or 10 raised to 9 hertz. So these are the three frequently used units. Primary unit is hertz, If we use hertz with kilo, then you can represent it using 1000 hertz. If mega is there, then it is 10 raised to 6 hertz. If giga is there, then 10 raised to 9 hertz. So this is about frequency. For wavelength, this is a notation for wavelength. Lambda is used to represent wavelength. The formula for wavelength is lambda is equal to c divided by f, where c is the speed of light in meter per second. As you all know, speed of light is 3 into 10 raised to 8 meter per second, and frequency is in hertz. That's why meter per second divided by hertz is equal to, in meter you can get that value. So lambda is in meters. So this way you can use hertz unit for to represent value of frequency, and you can use centimeter, millimeter, meter or kilometer as well to represent wavelength. So when you learn about the concept of wavelength and the frequency, it will be easy for you to understand electromagnetic spectrum. Electromagnetic spectrum is nothing but the range of frequencies from, you can say, very low frequencies up to 100 hertz and very high frequencies up to the terahertz. So why we learn electromagnetic spectrum, we will see it in detail in a lecture number 8. Thank you.